Okay, question answer about radioactivity. And you'll recognise this question. It was from your mock. So it's kind of nice you start to realise you get the same questions coming up over and over again, which is fab. So energy from nuclear atoms can be used in medical diagnosis. Fluorine-18 is used in a PET scanner. So I made you revise all things about a positron, annihilates an electron, causing gamma rays, and then we sense the gamma rays. Because the gamma rays are produced 180 degrees to each other, we can find out the exact location. But now it just wants, why must they be produced close to the hospital? So we've got the idea that they have a short half-life, mark. And therefore, in order to keep the activity so you can measure it, it must be used quickly. So that's the basic idea. We want to have an activity we can measure. They've got a short half-life. We're going to have to right next to the place where we're doing the scan. Some tumours can be treated using alpha radiation or gamma radiation. So yeah, we can use alpha, but only in really serious tumours and really, really tiny weeny ones. So it says, why can the source of alpha be used inside the body, but the source of gamma can be used outside the body? So this is just checking, do you know that alpha has a low penetration? Do you know that gamma has a high penetration? And we know that alpha is highly ionizing and gamma is weakly ionizing, but we're just talking about the penetration. So alpha has a short range or low penetration, so ... needs to be placed in or right next to the tumour. And you can see if I'm placing it in a tumour, its range is so low it can only be used for tiny, tiny little tumours, which is why beta's used quite a bit more. Next part. So now we've talked about alpha, and then gamma has a high penetration. I'm going to say has a long range, ... so ... it can penetrate and outside the body through the air and then through the body. That's that done. Next one, in a controlled chain reaction of uranium-235, so there's uranium-235 92. Which of these could cause the nucleus to undergo fission? So we've learned we need to have a neutron with the correct velocity. That'll then get absorbed by the uranium to form an unstable intermediate, and then that'll split into some daughter nuclei and will propagate some new neutrons. Neutron, neutron, neutron. And then these will then go on to cause the chain reaction. So crucial answer, which of these could undergo fission? We're going to need to fire a neutron at it. Next one, let's have a quick look at this. Oh yeah, nice question. So the kinetic energy of one of the particles is this. The mass of the particle is this. Calculate the velocity. So you go and have a look in your equation sheet and we can see, well, we know Ke equals half mv squared. Spent a lot of time trying to support you in rearranging this. We want to work out the velocity. So I can see v, well, best way to get rid of a half is multiply it by 2. So now I'm left with 2Ke equals mv squared. Now I want to get rid of that m. So I now know 2Ke over m equals v squared. Next part, I want v on its own, square root the whole thing, and then we're done. So I'm going to rewrite that equation, get rid of all of this, and we can just see, so rearranging that, which I've just done, you can replay it to your heart's content to practice this. If you can't do it, just learn your rearrangements for V and M, because it will come up. Oh, dodgy. Yay. Okay, here we go. So V equals the square root of 2ke over M. V equals the square root of 2 times 1.2 times 10 to the minus 11 divided by the mass, which is there. 1.4 times 10 to the minus 25. Put that into a calculator, and it's gonna, in fact, I'll just look at the mark scheme. There we go. Equals 1.3 times 10 to the 7, and that's just gone to the right number of significant figures there. There we go. And I'm expressing it. The reason why those significant figures are correct, I'm just replicating what I've got in front of me. If I went to 1.31 times whatever it is, I'm adding increased precision, and I can't do that just by manipulating data. That's that one done.